So everybody has this. You will need this script called DLA create, which I shared last week. Do you have this? And this one we did in week second, multi-objects. So we are going to copy paste some of the methods from these two. So please have it on your computer. It's called multi-objects and DLA create, which is on the Google Drive. Okay. So let me bring that DLA create here to show you what I'm going to do. So let's create a folder called scripts. And I'm going to bring, that was last week. So last week I have DLA create I shared with you. And let's double click on it. Okay. And here, just make sure that this add DLA agent inside update function is turned on. I think I accidentally turned that off before I share. You have it on? Okay. And then just to show you what it does again, we make a prefab. The reason I'm starting from scratch is it's not much work to just make some new prefab, but I'm repeating. So if you are working on your new previous project, it's totally fine. But I'm going to do from scratch if it's not necessary. Okay, so bring that cube to your prefabs folder and delete this. Oh, one thing I realized that you make some mistakes. So I'm going to tell you what's going to happen. If you drag the prefab from hierarchy versus dragging the prefab from the prefab folder. So let's make a empty game object called DLA and bring the DLA create script to the empty object. If you do that, it's going to ask you a input prefab. And some of you make this mistake by dragging the cube prefab from the hierarchy instead of from the folder. Let's see what's gonna happen. So if you drag your cube from hierarchy, you play, it's gonna do the same thing. Yeah, it creates the DLA generation. Okay, that's fine. However, if you turn this one off, the entirely copied DLA prefab is going to be off. Yeah, you don't see that because it's directly copying the property from the scene. So you can feel free to delete it and instead drag the prefab from your prefab folder. So it doesn't matter what kind of local change you do to the scene. So bring the prefab from the folder and then you make changes. Okay, now even if there's no way to turn it off or change it. So if you want to change the property of the cube, you can double click on cube prefab from the folder and make changes from here if you want to change material or so on. Okay? Okay. So what I'm going to do is to code the DLA from scratch with you. Yeah. But to save the time, I'm going to copy paste quite some chunk from this script that we just used. Okay. All right. So let's delete this one. right click and create a new empty geometry. Name it slightly differently. DLA, my DLA. So you differentiate that from the original one and go to script. So let's create a new script called scripting mono behavior script. We are not making this into class, but if you are happy to learn more about it and if you want a challenge, I suggest you to make this into class. Yeah, by yourself, and I can help you. DLA or my DLA. So I differentiate that from the one that I shared with you. Okay. And drag that to my DLA and double click on my DLA. So now you have this script here. I'm going to delete the comments. So we don't need to have that. Okay. All right. So in the start, we are going to set up the scene. So what DLA is, let me just draw a simple diagram here with the zoom tool. So what DLA is, so you need to start with a seed. So let me change the color. So you start from a seed, yeah? And then what I'm doing is I make a random generator every time when I update, yeah? And then I search from the seed that is already generated. I search the closest one and make this vector, yeah? And then set this length either randomly or specifically. And then I grow another seed next to it, okay? And then what I do in the next update, I make another random generator, okay? And I search from these two. I find the closest one. This one is closer. Then I make a vector, define a length, and then I generate the third one, okay? And I just repeat that all the time, yeah. Then you can guess my fourth generation, I generate this one randomly. And then I find the closest one. Maybe my closest one is this one. And then I make a vector. I define the length and make a new one there, instantiate a new one there. And I repeat that and eventually it grows like a branch. So the principle is really simple. So it's called diffusion limited aggregation, and that principle is a natural phenomenon. Yeah, it's a similar phenomena from thunder, from branches, from coral. Yeah, so that's the principle, and it's really easy to code that. Yeah. So in the start, we are going to bring one game object that is a public game object and input prefab, save it. And then now I go back to Unity. And now it's asking for a new prefab. I go back to my prefab folder and bring that in. And then I go back to my script. And then in the start, I'm going to generate one prefab. So, sorry, let me close this. Okay, and then game object, new prefab is a instantiate. This you're familiar. The input prefab on a certain location. For now, let's put it in vector 3.0. And quaternion dot identity, meaning no rotation, and transform. So now you created the first seed, correct? Okay. All right. And in the future, we need to search from the group of all the seeds that we generated, right? So whenever we generate the seed, we are going to put them in a list. So we are going to define a list of game object, then all prefabs. And in the beginning, I'll define that as a null. All prefabs. Okay, so this is erroring, right? So right click, quick action, and using, yeah. So it suggested a solution and it added a new using statement. So do that, and inside start, you wanna make the list of prefab, copy that, and add the newly added prefab inside.
What does null do?
Null meaning nothing. Yeah,
So
so
it
just to
starts empty?
prevent, yeah, just to prevent error. Okay, and do you remember I was drawing the blue dot? Yeah, so we are going to make another copy of this cube. You could have just made another input just to differentiate it, but I'm going to use the same one and ask it to generate it every time randomly. Okay, so what we want to do is it's private, or if you don't say private, it's going to be private. Game object. DLA generator. I'm trying to match the name with the previously given one. Yeah, and then inside start, we don't have to do much, but here we are going to do this. So inside, the reason I'm putting this here is because I want this to be read from update as well. So DLA generator is a new instantiation. So copy this line, Control C, Control V, but delete the transform. So we don't want this to be a child of this object. And then I'm going to change the name of this generator. Game object dot name. You can define a name and then quote as a string, say generator. And then I'm going to scale this a little bit just to show the difference. So transform dot local scale new vector 3 0.5f 0.5f. So it's half size. And I want to make this blue. So generator dot get component mesh renderer. This is accessing your material. Material color is, I'm going to give a blue color. So new color. and we are going to give a number. So from 0.5, 0.5, it's RGB. So R, G, and B is 1 point. So I gave you can put 0, 0, 1. I just gave a little bit of number there. Okay, and one thing I want to do is also turn off the box collider. Okay, let's not do that. I think it's not necessary. Okay, so let's keep this lines. So this is a bit too much lines, but it's understandable, right? There's nothing difficult to understand here. So once this is done, you can try to play. Yeah, so play. So you can see that now one cube is generated here. I think it's not, didn't do it. My generator input and instantiated with a generator name, not set to an instant. If something was wrong. Oh, so it doesn't work because I didn't open the empty list. So before you do that, all prefabs is a new list of game object. So you need to assign this value of the list so it's finally can accept other objects. So now you play. Yeah, now you see there's a new generator generated inside 0, 0. And there is a cube generated inside my DLA. So it's parented. Okay. So now let's update this. So when you update, I told you I want this blue marker to generate in different areas. So what I'm going to do is I'm going to show you a reference. So I'm going to make this into 40 by 40 by 1 scaled platform. So I'm going to generate the DLA within this area. Okay. This is just a marker. So I'm going to turn this off, but it's going to be helpful. Okay. So inside update, what you want to do is make a new vector. So vector 3, DLA direction is a new vector 3 and random dot range. And I'm going to give from -20 to 20 because we want to have 40 by 40 scale, right? You can copy this 3 times. So Control-C, Control-V, comma, Control-V, and semicolon. Now you want to position the DLA generator transform dot position is this new position. So you see that now the blue generator is everywhere. Okay? Are you okay? All right. So now you have to concentrate because this you need to think. All right. So we said we are going to test the closest one and get the direction, right? So although the first round we don't have much, but we have to consider that this blue thing is testing from a group of geometries. So just bear with me, go back to your DLA create, and we are going to just cheat. by copying a method from here. So here, there is a method called getClosestGeometry. So what this does is it returns a game object, and you only need to give a test vector and a group of prefabs. And then it's going to return you the closest one. So copy this and copy this, paste this to under update and inside the class. Be careful with the parentheses. Control V. Okay, make sure after this is inside the class. Okay, now we can use that. So what we need to do is we need to do this thing. So assuming we have already many seeds, so they are group of geometries. And now I have a random point. So first thing I need to do is I need to get the closest one, right? So that's what I'm going to do now here. So I'm gonna get the closest one. So vector 3, growth direction is, so this is actually getting me a prefab. So before I do this, I'm gonna comment this out first. I'm going to get the game object first. Game object, the closest geometry is get closest geometry. Then we need to feed two things. One thing is the vector that I want to test from, and the group of geometries that I'm going to test. Does it make sense? And this is going to return you a game object, not a vector. So now you can use this to get the vector by getting transform position. Sorry. So one more thing we need to do. So closest geometry's position is this position, right? This one, okay? And my location is DLA direction, is this one, correct? So DLA direction is this one. Closest geometry is this one, right? But what we need to do is we need to get this vector. And then we need to scale it down. Yeah? So in order to get this vector, if you forgot about vector math, if you have a vector A and vector B, in order to get a vector to point from B to A, you need to minus this like this. Yeah. So basically what we need to do is we are minusing the DLA direction and the closest geometry's position. So what we need to do is DLA direction minus closest geometry transform. But this is a long vector, very long, right? So we need to scale it down, correct? So what we need to do is we need to dot normalized. We need to normalize this vector. And then we are going to give a number. So it's not just one. We can define a number. Is that okay? So I'm going to make this number as a F density and make it into a public variable. So bear with me. Go all the way up, up, here. And I'm going to make a new public variable, public float. F density is by default. I'm going to make it slightly bigger than 1. So you can see the distances between the cubes. And if this is public, now you can change it while you play it. Okay, now this vector, so what did we do? I'm going to draw this again. So let me know if it makes sense. So we created DLA direction. This is a new position, generator position. We found the closest one, yeah? And we generated this vector. And then we scaled it down to 1 scale, normalized, yeah? And then we time that to a specific number, so you can scale this. So this length is F density. Okay, so that's how we did it. All right, now we need to add a new geometry there. So vector 3, a new position. The new position is not that vector. It's a vector added to that closest geometry. So the new position is closest geometry transform position plus the scaled growth direction. That's the final position. And a new game object is added now. New prefab is instantiate the input prefab on this new position. With no quaternion rotation, quaternion identity, transform. So you parent it. Control S to save it. It's really simple, isn't it? Now, actually, you are done with DLA. So now I'm going back to the script. Now let's go snap. Okay. So now you can change the size. The density, you can change the density. Let me see why this is so big. So unity cube is 1, 1, okay. And my DLA, the default value was 1.2. So it should be less dense than that. Okay, it's going very dense. Because it's probably not finding, okay, okay. Because it's not really spreading, it's always, okay, so I can just change the number of density so it gets stretched a little bit. You see, but it's kind of going quite rounded. Okay, that's fine. So now we can do a few more things. This one is slightly different from the DLA create version. What I want to do is to snap this to terrain. So don't worry about it and just follow me. So I'm going to turn on this cube. So I want to make the terrain in this size. Right click, folder models. And then I'm going to bring my terrain model again. models. I have this terrain model. Which one was that? Let me use the previous one. So terrain model. Okay, terrain model. Yeah, this one. I'm going to also bring this image as well. Create folder, images. I'm going to bring this colorful one as well as this real map, this one. Yeah. Okay, so do you remember when you want to read the color, you need to have read and write enabled. So we are not gonna read this color, we are gonna read this color. So read and write enable. Go back to your models, sample site, and read and write enable, apply. Okay, now you can drag this in here. We can scale this down around that size. You can also go to top view and you can toggle ortho and then scale this around 40 or slightly bigger. Slightly bigger is safer because we want to let this grow. Okay. And then on the side view, I'm going to make this be around this area and stretch it higher, something like this. So let it be around 0, 0, like that. And turn off this grid and right click, prefab, unpack. And because here we don't have mesh information, so bring this out, delete the parent. So we just need the direct geometry and rename this as terrain. Just to get rid of the parent. The parent was an empty object. Okay. And then we are going to make a material that has the texture. So, so I'm going to make a new folder called materials and bring the new material inside there. Change the material name. Right click, rename to terrain map. And bring that image, colorful image to the base map and apply that. Okay, just to show you the impact of color. Okay, so what I'm trying to do is while growing, also snapping to the terrain. Okay, so let's do that by going back to our script. Okay, and bring back the script from last week 2. So the one I was looking for was week 2, which I shared. It's called multi-object. So double click. Yeah, so here, go all the way down here, and then we are going to copy this. Yeah, this one called snap to terrain and get color. So copy the entire method. Make sure you don't confuse with the parentheses. Control C. Go back to my DLA. Go all the way down. Make sure it's inside class. Control V. Okay, in this case, we can call that function. So I'm going to call this when I first generate my first seed. Okay, so here, before I instantiate, I was instantiating in 0, 0, 0 position, right? But before I do this, I'm going to make a new position. Vector 3, new position is a snap to terrain. So I'm going to go down, copy, Control C, Control V. Then we need a vector. So the first vector, I'm going to use 0 vector. And out color my color. So if you're curious what out is, I can explain you later. And then if you do that, it's going to snap and the half of the chunk is going below grade, right? So I'm going to just bring that half forcefully. So add a new vector and 0 input prefabs transform local scale dot y and times half. Does it make sense? And 0. Just forcefully bring it up. And then instead of 0, I use this vector to snap it. So in update, we are not doing this yet, but let's see if there is an impact, okay? So if I hit play, okay, it didn't snap. Why? Because the terrain doesn't have a mesh collider. So add a component. Now it's snapped, but the newly generated ones are not snapped. So we will fix it. Okay. So here we can actually copy the entire script, Control C. And before we instantiate this, we can paste this here, but instead of declaring this again, we say, okay, new position. Okay, it shouldn't be new post, should be pose. Okay, pose is snap to terrain, snap the new location, and have a color replay. Yeah, so that should be correct. Yeah, and let's see if everything gets snapped. So once it's snapped, the result will be slightly different. Okay, so now there is an error. The reason is because when they start to snap to these boxes, they're not really grabbing any color because they don't have texture map. So we need to fix few things inside the snap to terrain and get color here. Here we get the texture map from terrain, right? But the boxes doesn't have terrain, doesn't have texture, right? So the boxes, so if texture is null, you have to put two equivalent. We are going to do something else. And else, if we have texture, we are going to do all of this inside. So these colors are picking the color from the terrain. And this can only happen if you have a texture map. But to prevent that, prevent the error, we can say, if you don't have texture, you just get the material color. So material color you can get from rand material dot color. And if it's snapping to a box, it should be blue. It should be white now. Yeah, now it's growing. Ooh, okay. So it's going too high, right? So we can make the generator to be more spread under. So here, instead of making the range of Y too high, I'm going to reduce it to what's a good number? I tested it already. Okay, so 0. So from 0 to 0.5. And if it's erroring, you put an F. Okay, now it should spread. So now we see this problem. Everything is growing in the center and growing just very tall. That I just realized that it's because I didn't add the newly added seed into the entire list. So the generator is only searching from the first one, not from the entire group. So it was a really easy fix. You can go to your MyDLA script, edit script, and you can see that when in the start, when we generated the new geometry at the end and the beginning, we added that to this whole list. And then everything is testing the closest geometry from that group. And then when we made the new ones every time, but we didn't add it to that list. So we have to just copy this line, Control C, then Control V to this line. Make sure this and this has same name. Control S, and now it should fix the problem. Now if I play, yeah, everything is growing properly.